Alright, now we're ready to actually create our footprint here. And to create the footprint, we go into OrCAD PCB editor. And one thing you want to make sure, though, before we get started is that your paths are set up correctly. If you go into, I'm sorry, I went through there a little bit fast here. So if you go into Setup, User Preferences, and then it's under Paths, and then under Library, and then you have pad path here. $pad path is just a default directory that things are stored. For Cadence, you need to put in the directory that you have stored your pad stacks in. You need to do the same thing in the PSM path. This is where you need to put what footprints, where the footprints are going to be stored. You don't need this for actually creating the footprints, but you'll need this for when you do layouts. And again, $PSM path is the default directory for Cadence. But anytime you create your own custom ones, you should put them in a separate directory. Okay, so those are all set, so I'm going to make sure to hit apply. Okay. Now we're ready to go ahead and start a new package. So we're going to do package symbol, and we're going to go ahead and do the wizard. And we can do the wizard because this is just a simple component here. Now, you also want to make sure that I like to make sure that my directory here is set for where I'm going to be storing the footprints. So you really want to give it a better name than what I'm going to do here. I'm just going to call this footprint chip resistor, or chip res. Alright, then it's going to open up the wizard. Now you have to select what type of component you're doing. There's a lot of different types of components. DIP is dual inline package. Those are the components that we typically put into a breadboard. So anything like that is going to be a DIP package. SOIC, surface mount component, standard layout for a surface mount component. PLCC, just basically you have leads coming out of all four sides. BGA is ball grid array. These are actually some interesting components. Microprocessors for like computers are similar to a ball grid array. Their pins, though, is what are on there. So if you've ever built it and you know you have to drop your thing down into the slot and then tighten it down, that's kind of like a ball grid array. Through-hole discrete, those are of course like resistors and capacitors that you'd put in a breadboard. Those are through-hole discrete components. Surface mount discrete components, that's what we're going to be doing. Those are like chip resistors, chip capacitors. Single inline package, those are often used for headers, other things of that nature. And then you also have a zip package as well. So let's go back to the SMD discrete, because that's what we're doing. And then you hit the next screen. Before you can hit next, you have to load in a default template. Now, I have a slightly different version of Cadence than is installed on the computers in the classrooms. But if you click on load template, you might get an error saying here something or a warning. Just go ahead and say yes or okay, and it's fine. But you do always have to load the template first. Then hit next. And we'll go ahead and switch these back to millimeter. And then the designator prefix is the fact that, remember, when you're building a circuit in Cadence, any resistor has like R1, R2, R3. Well, when you put them on the boards for layouts, you do the same thing. And so you can do, for resistors here, since that's what we're doing, we'll do R star. Star just means it's going to append whatever number is associated with that particular component. But you don't have to use anything from that drop-down menu. You could do any letter you want. Like, for instance, you could do G star. But again, since we're doing resistors, let's just do R. Next. Now, we've got this here where we just need to enter in what the dimensions are here. So it's got the terminal spacing, E1, and that's the spacing, it's the terminal pin spacing, it's the spacing between the pins on the component. And then we also have the package width. The package width is then also designated as E, and then we have the package length designated as D. And so we need to go back to our diagram here and discern what those things are. Well, W clearly is that package width D that we're interested in, which W for the one we were doing was 3.1. So let's go back here and just go ahead and enter this as 3.1. And now we have to figure out package width and terminal pin spacing. Now the terminal pin spacing, you don't want to get confused by these here. This is really kind of illustrating how the pad stack is going to be put down. So let's go back here and see what we have here. Alright, well there's this L here, which you might think is the package width, but really that is the spacing from the very edge of one pin to the edge of another pin. And so you could think of that as the terminal spacing. However, it's usually a good idea to make the terminal spacing to be in the middle of these pins. Now notice there's this dimension I2 that's on the bottom here, and that's where we're going to be mounting things. So it's 0.5. So half of 0.5, of course, is 0.25. So if I think about here being 0.25 in from this side, 0.25 in from this side, that's going to be my terminal spacing. Or you can just think of it that you're going to just subtract 0.5 from L. And my L dimension is 6.35. So 6.35 minus 0.5, 5.8. I can't do math in my head right now. 5.85. There we go. 0.5, that would be 6.35. Yes. Now we need the package width in millimeters. And the package width in millimeters is the actual package itself. So like this, taking out the pin portions of it, what the package is here. So that package width here, I'm sorry, the package width, yeah, did I say that right? Yeah, the package width here is, I want to make sure I say it correctly here. Package width is, we'll define here as the actual width here between these two things here. So I'll subtract off 2I2. So I'll subtract off 1 millimeter. So this would just be 5.35 millimeters for E. Then we click Next, and we have to tell it what is the default pad stack to use for symbol pins. And that's where we come up here and we choose them, and then this has all the pad stacks that are in my pad stack directory plus all of the ones that are in default and cadence. How do you know what these are? Because you can go to the text here and you can actually see what some of these are here. So if you want to see here, for instance, what some of these are, let's look at SMD 3031. So the begin layer is a rectangle, the bottom layer is a rectangle, but the thing is I don't like is it doesn't really give you much as far as dimensions. So you really would just have to open it and to know what it is. And these are in mils. But we already created one, and we created a pin name that wasn't great, but we did it on purpose because it's the first one. And then pad stack used for pin 1. You can actually choose a different pad stack for pin 1. This can be helpful for when you're doing surface mounting of through-hole components, and you're wanting to, not surface mount of through-hole, if you're doing through-hole components and you want to make sure you have the rotation properly, you can make, for instance, instead of it being a circular thing, you can make it square. Not necessary though. So then we'll click Next, and it's like select the location of the origin, just center the symbol, and then create a compiled symbol. So Next, and then Finish. And it will take a second here. Alright, and now we've got this here. And I'm going to move some of this a little bit away so you can see this a little bit clearer. Let me just close this out. I suppose I could just zoom in here. So we can see here pin 1 and pin 2. Now this is the rectangle here. This little rectangle is that package here. And that package, again, remember, is not where the electrodes are. So this is where the electrodes are. And we can see all these different little layers here. I'm going to zoom in on this. It's saying pin 1. This purple one is what would be etched in copper. This inner one, I'm sorry, the purple one is the solder mask. The inner one is what gets etched in copper. And then this pink one is where the solder paste would get put down. And then it labels it pin 1 and pin 2. And there we've got a footprint for a chip resistor. And then at this point, all you need to do is make sure to save it. It's already saved, and that's it. We'll do another video of doing a footprint, and in that video we'll actually do a through-hole component, and we'll do like a dip package for like a 741 op amp.